Greetings. I'm going to be talking about circle geometry. I've chosen three concepts. The first one is when the angle created by two secant lines intersecting outside a circle. The second, a secant line and a tangent line intersecting outside a circle, and finishing with two tangent lines intersecting outside a circle. I'm going to start with some prior knowledge that we're going to need. First off, we're going to need to know that the sum of interior angles sums to 180 degrees. This is something I've shown before, and I've chosen not to do it again. One thing I haven't shown is the remote interior angles theorem. This is relatively easy to show, and on the right hand side I've done that. The goal is to solve for D. We already know that, and by showing that dagger and psi both equal 180 degrees minus C, meaning they equal each other, we can then say that the sum of A and B, i.e. the remote interior angles, is equal to angle D, the exterior angle. Another concept we're going to need is that the measure of an inscribed angle is equal to 1/2 the measure of the central angle, where the central angle is equal to the measure of the arc it creates. I've shown this before, but I thought it'd be worth showing again, and these three proofs demonstrate this concept for when one of the secants goes through the center, when the center is outside the angle, and when the center is inside the angle. This is our first concept, and just to reiterate, we know the things we know. The arc measure is the measure of the central angle that it forms it. Inscribed angles are equal to 1/2 the measure of the central angle. And the remote interior angles theorem. This first concept is two secant lines intersecting outside the circle, and we use our knowledge of remote interior angles, and we drop a chord from D to C, and there we can see that phi is equal to lambda plus alpha, but we know from previous proofs that phi and alpha are inscribed angles, and we use our knowledge of that to solve for lambda, and we end up with lambda is equal to 1/2 the measure of the larger arc DE minus 1/2 the measure of arc BC, which is the smaller arc. And a good way to remember this, and I believe I said this before, is that it looks like a minus sign inside of the circle. Next, at the top, we have a tangent line and a secant line intersecting outside of a circle. Again, we're going to drop a chord from C to D, and then use our understanding of exterior angles to solve for lambda. So we know that psi is equal to lambda plus alpha, which we can rewrite as lambda is equal to phi plus minus alpha, psi minus alpha. And again, from previous proofs, we know that psi and alpha are inscribed angles, and we use their measures to solve for lambda, and we get our final result, which is lambda is equal to 1/2 times the measure of arc CD minus the measure of arc BD, where the CD is the larger of the two arcs. And finally, we have two tangents intersecting outside of a circle. Again, we're going to drop a chord from B to C, and we're going to use our remote interior angles theorem. So we say psi is equal to alpha, or lambda plus alpha. We can rewrite that as lambda is equal to psi minus alpha. And again, we can see that alpha and psi are inscribed angles, and we can use their measurements to solve for lambda. And we get our final formula, which is lambda is equal to 1/2 times the measure of BD minus the measure of BC. Again, it's important to remember that we're subtracting the smaller arc from the larger arc, we can't get negative values. For this one, it's also important to remember that because these lines intersect the circle at one point, we need to either make clear or create another point on the circle so we're not subtracting BC from BC. So what I did is I implied when we're coming from the left, we use point C, and when we're coming from the right, we use point D, just to reduce confusion. And those are the three concepts, and we used our knowledge of interior angles, our sum of interior angles theorem for our triangles, our remote interior angles theorem, and our knowledge of inscribed angles. Thank you very much for your time.